Hello, my name is Brett Molyneux, and in this tutorial, we'll be going over the Shared Key Symmetric Authentication use case for the Trust Platform Design Suite software. So let's get started. So here we have our device interface architecture. On the left side, we have the host device, which is protected by a SHA105 security IC. And on the left, we have the client device, which is protected by either a SHA104 or a SHA106. So some of the advantages of Shared Key Symmetric Authentication is that it is very easy to implement. All you need is to put the same master key into both the client and host device. You can also leverage down to very small and cost-efficient MCUs, down to the 8-bit MCU, which can allow for easy integration into your already existing designs, or if you have any constraints on a project, it can help with that. The last pro we have here is that the master key on both the host and client device are going to be protected in a tamper-resistant secure authentication IC. And this would be our SHA devices, such as the SHA104, the SHA105, and the SHA106. Now, some of the drawbacks to Shared Key Symmetric Authentication is that if the master key on either the host or the client were to ever be compromised, then the whole fleet of devices would be compromised. Another risk that really applies to any type of authentication is that there is a risk of the master key being exposed during the manufacturing process. And to prevent this, we provide Microchip secure provisioning service, which should eliminate any of those backdoors during manufacturing. So here we have a representation of the host device and the client device in the field. For the host, we'd have a SHA105 device on it, and for the client, we'd have a SHA104 or 106. And to start this process, we would put a symmetric key in both the host and client device. Then when the devices interface in the field, the host is going to send a random number challenge to the client, and both the host and client will take this random number challenge and hash it with the symmetric key into an algorithm such as SHA-256. This is going to produce a response that the client will then send over to the host, and the host will run both responses through a compare function, which will determine if the client is allowed to interface with the host. So what we'll need for this use case is the Trust Platform Design Suite software. You'll also need the MP Lab software. For hardware, what we'll need is the CryptoAuth Trust Platform Development Kit, along with the SHA104-105 mikroBUS evaluation board. And then in addition to all that, all you'll need is your laptop and a micro USB board. So let's get started with implementation. All right, so here I have opened the Trust Platform Design Suite software. If you need any information on downloading the software, please go to the links below in the description. So to get started implementing, we're going to go to the Use Cases tab. And in this use case list, we're going to scroll to the bottom, and this is where Shared Key is. Select Shared Key, and then scroll to the device options, and we're going to select the SHA104. This is going to open a window for the use case where we're going to implement it into our development kit. Here we have just a general description of the use case. Here we actually have a description of each of the types of symmetric authentication. If we click this arrow here, we can see our cryptographic assets list. So you can see for both the 104 and the 105 that the master key is going to go into slot 3. And then here's the steps of what we're doing right now, actually executing the use case. When we scroll down further on the use case page, we'll come to this transaction diagram. This is what we'll use to provision our development kit. This just shows the provisioning process where we generate the key and implement it in both devices. And then here is the in-field actual runtime, the steps that would be executed for authentication. So before we provision our development kit, we actually need to configure it. This line here describes how we need to go back out into the configurators and set up the devices for SHA104 and 105 so that slot 3 is assigned to have that key. So we'll go back out to the Trust Platform Design Suite main page and click Configurators. And when we scroll down this list, we see the SHA104 and the 105. We're going to open the SHA104. This opens the configurator, and in this first part, we're not going to select anything up here at the top. We're going to scroll down and select your device interface. You'll also need to disable the limited key use. And without clicking anything else, we're just going to click Provision Prototype Samples. Click OK and OK. And now slot 3 on the SHA104 is ready for that master key from the transaction diagram. Now we're going to go back out and do the same thing for the SHA105. So do not select anything at the top of the page. Make sure you select the device interface and make sure limited key use is disabled. And then without any other inputs, we're going to click Provision Prototype Samples. OK and OK. And now slot 3 on the SHA105 is ready for that master key as well. And now we can go back to the use case window, and we can actually execute all the steps in this transaction diagram. So the first thing we're going to do is generate the master symmetric key and input it into the host and accessory device. We need to put in a little input here. I'm going to select the device interface and then generate a key. Click OK. And we can see that this step was executed successfully in the output window here. Next is when the devices are actually in field. This is the execution that they'll do. So we'll click 1, and the host is going to generate a random number challenge and send it to the accessory. The next step is for the accessory to produce a response to send back to the host. And as we scroll down here, we can see all the steps are being executed. And the last step, the host is going to check that response with its own to make sure they match. And we can see that the whole use case execution was complete. So now that the development kit you have is completely provisioned, you can actually go and click MPLab Project, and this will just open MPLab to the project with all the files you need for this use case. And now the next steps, you'll either need to create more prototypes or you're ready to get your first verification units. So I'll go into that process, which is detailed in the conclusion here below. So next we'll go back into the SHA104 configurator, and using the configurator to get your verification units and create new prototypes is actually very similar. We're going to select the use case, which is Symmetric Authentication. You select the device interface, and when we scroll down here to the bottom, you can see that slot 3 is highlighted. When we click slot 3, we can input the key, which is 32 bytes. You can either enter your key as hex data here, or you can upload it through a .pem file. So if you're making more prototype devices, you can either generate a provisioning package, which will download the file of the configuration to your computer, making it easy to put onto more new devices. Or you can click Provision Prototype Sample, which will provision whatever connected device you have for this use case that is connected to your computer. Now, when you want verification units, you'll click Generate Encrypted Provisioning Package. This will open a window asking for a code. Microchip will provide you this code on Salesforce. So when you input that code, a file will then be downloaded to your computer, an encrypted file, and that's one of 4 files that you need to give to Microchip to get your verification units. The other files, one of them is the file from the SHA105 configurator. You'll do the same exact process as you did for the SHA104. Input your key here. When you're ready for your first verification units, you can go to Salesforce and Microchip will provide you with an RSA key. With that RSA key, you can come and fill in your configuration in slot 3 using your real keys for your project, and then click Generate Encrypted Provisioning Package, which will prompt you to insert your RSA key. And with the RSA key, you'll be able to download the encrypted configuration file. This will be one of 4 files that you need to provide Microchip on your Salesforce ticket. The second file is the configuration for the SHA105, so you'll fill in slot 3 and then click Generate Encrypted Provisioning Package. You'll then put in that RSA key again, and you'll have the second file downloaded for your Salesforce ticket. And that's a wrap on this use case implementation. If you want any more resources, you can look to the description below where we'll have related content, or you can look through our YouTube channel for any other use case videos. Thank you for your time.